Hi guys, welcome to another MCQ discussion session at Medico Apps. I am Dr. Abhishek, your mentor at Medico Apps. And today's question, which appeared in NEET PT, is which of the following variant of PCR can amplify small amount of target DNA in a sample contaminated with other DNA? Okay, and your options are arbitrary primed PCR, multiplex PCR, nested PCR, and real-time PCR. Okay, so these are the options. Now, PCR is a very important topic, but PCR everyone is able to answer it. So now they've started asking a lot of questions on variant of PCR, and every year I'm seeing one question on variant of PCR. Before I start discussing the different types of options which are given in the question, I will make you a small request. If you have still not subscribed to Medico Apps channel, if you are new to the Medico Apps channel, make sure you hit the subscribe button and make sure that you hit the bell icon so that whenever I upload such MCQ discussion sessions, you are notified. You can watch those sessions, and not only MCQ discussions, we are going to upload a lot of high yield topic short videos, high yield topic videos, which you can use it, which you can learn very fast. So let's start with the discussion. So the first variant which I want to discuss is your reverse transcriptase PCR, and this is very important because COVID, you know we detect by RT-PCR, okay, also called as reverse transcriptase PCR. Now we know that PCR is basically polymerase chain reaction, and there we primarily can amplify DNA. So using our traditional PCR, we cannot test for mRNA or any kind of RNA. Okay, so just to make sure that we are able to use this versatile technique even for measurement of RNA, what we do is we take the RNA, okay, and we use reverse transcriptase enzyme and convert it to a copy DNA. Now once we have got a copy DNA, that is a double stranded DNA, we can now use our traditional PCR to amplify it. So here what is happening is it's a modification of the PCR where we take any RNA. It can be a mRNA, it can be a tRNA, or it can be a ribosomal RNA. Okay, and that is what we do is we convert that ribosome, RNA into a copy DNA using this enzyme reverse transcriptase, and then we do a normal PCR. And obviously, why it is useful? It can be useful to detect RNA viruses. It can be useful to detect gene expression, because gene expression means formation of RNA. Okay, and here all the Taq polymerase and everything is same. Only thing is we use a reverse transcriptase enzyme. So this is your first modification. Let's look at the next modification, that is called as real time or homogeneous or kinetic PCR. Now what happens in PCR? PCR is basically it's not giving you a quantitative analysis. It is only giving you a qualitative analysis. That is the virus segment present, or is the DNA segment which you are looking is present in the sample or not. What if you want to measure the quantity of the DNA which is present? For example, I'll give you a patient comes to you for the first time, and you want to see if he is suffering from hepatitis or not. So you order a PCR, and that will tell you that yes, he has that viral DNA in his sample or not. But next time, let's say you started him on treatment, and next time you want to know the viral load. Has the viral load come down, or has the viral load increase? And for that you will need to have a quantitative analysis. So this modification is basically a quantitative PCR. Okay, so here what happens, there is a simultaneous amplification as well as quantification. So how can you quantify? Basically, if you are able to measure how much amplification has happened in real time, you will be able to quantify. So what do you do for that? You add some kind of dye or some kind of probe. So there are two kind of dyes which are there. So one is ethidium bromide, which is now not too much used. The more common used is SYBR green, and there are certain probes, and the probe names have been also asked: Tachman, FRET, and molecular beacon. So all these probes, I'm not going into detail, but remember, if you are able to put a dye which will tell about the which will be measuring the amount of amplification which has happened, or any probe which can tell us in real time how much amplification has happened, so that converts our traditional PCR into a quantitative PCR. So this is the second option. The third, there are another two modifications. One is nested, and one is multiplex. So multiplex is much simpler, and let's look at both of them one by one. So what is nested PCR? Nested PCR, what happens, and I'll give you an example of nested PCR. Suppose you go into a crime scene, okay, and the victim blood is there. Along with the victim blood, there is also the criminal or the assailant blood. So what will happen? because the victim DNA is so much, you will not be able to amplify it, with our traditional PCR. So what we use is nested PCR. So here what happens, if the DNA to be amplified is in low concentration as compared to total DNA in the sample. And what we do is typically we use two sets of primer. So what we do is first we amplify with an outer primer and then we amplify with an inner primer, and that leads to basically concentration. So first we use an outer primer to amplify the DNA, and then we use the inner primers to detect it. So basically two sets of what will happen is two sets of PCR is done, one with outer primers and one with inner primers, and thus increasing the sensitivity and specificity of the PCR technique. So this is your nested PCR. The next is multiplex PCR. Now what happens is typically in a PCR technique we generally identify one segment. What if we simultaneously want to identify multiple segments or multiple target sequences? So this is your multiplex PCR, like a multiplex movie theater where you have multiple movie running at the same time. So simultaneous amplification of multiple targets in a single reaction. And obviously because the more number, so you will have to use multiple primers for it, as many you want to discuss. The last modification of PCR, again it has been asked, is arbitrary PCR or arbitrary primed PCR. It is also known by some other names like randomly amplified polymorphic DNA or randomly amplification of polymorphic DNA, RAPD. So all these names you have to remember. Now what is this? I'll give you a situation. Let's say there is a grasshopper and you are exposing that grasshopper to, let's say, a cytotoxic drug, and you want to see if it is causing some mutation in that grasshopper or not. So you are not sure as to if what kind of DNA changes you are going to look at. Okay, so we are not very sure that what kind of DNA changes will happen after the exposure to the cytotoxic drug or any external toxin. So in that case what you do, you use sort random primers. So you are just sequencing random using random primers, and so anonymous stretches of DNA under low stringency are you know yeah, and that is why it is primarily used in what you call research. Okay, and obviously because random primers are used, the reproducibility is less. So when you are doing research work, when you don't know what kind of DNA segment you want to search for, then you use random primers, okay, just to amplify random segments of DNA, and it is primarily used in research. So this is your arbitrary PCR or arbitrary primed PCR, again a very important here. So let's come to the question. So it's a now with once you have learned all the different types of PCR, this question becomes very easy. Which of the following variant of PCR can amplify small amount of target DNA and a sample contaminated with other DNA? The correct answer will be your nested PCR. Multiplex PCR is for multiple targets. Okay, this is for random segments, primarily used in research, and real time is just a quantitative. Okay, because it uses dyes or probes. So this completes our discussion. I would like you to, give you a little here. I am sending daily updates on WhatsApp to all my students, and I've created a special WhatsApp group for your first year students, second year student, third year students, and so on and so forth. So if you want to get notifications of these live lectures or discussions or important high points or topics or PDF, make sure that you join the WhatsApp group. So those groups you can find on medicoapps.org/groups. The link for that groups will be also in the description, and once you go, choose according to whatever. If you are a first year student, choose first year, because you will get only updates related to the first year subject. So this is very very important, and because we can have only limited number of students, we can say updates to limited number of students. So make sure you join before those groups fill up for this year. So thank you so much, and make sure that you are again subscribed to our YouTube channel and you hit the bell icon so that whenever we upload you get a notification. Thank you so much.